well, folks. So, in case you need these findings later on, we'll be happy to like share those resources with you as well. You can rewatch it. You can get the resources as well, which we'll share during this session. So, starting out with cloud, I always start with a journey. तो इनिशियली व्हेन आई यूज्ड टू थिंक कि मेरे को अपना एक वेबसाइट या फिर कैसे होस्ट करना है, कहाँ पे होस्ट करना है। अभी लाइक आई थिंक हाउ एवरीवन स्टार्ट इज वी मेक आवर ओन पोर्टफोलियो और वी मेक आवर ओन वेबसाइट, राइट? नाउ सेकंड थिंग्स कम्स कि अभी उसको ग्लोबल कैसे करना है और हाउ टू मेक इट रीचेबल टू एवरीवन। फॉर एग्जांपल ड्यूरिंग माय फर्स्ट ईयर इन माय कॉलेज आई मेड अ कॉलेज प्रोजेक्ट। आई थिंक एवरीवन मेक्स इट, नेशनल लाइब्रेरी सिस्टम, ओके? And then I showcased it to my HOD, and my HOD asked me like, "Can we implement this in our library?" And I was clueless how to do it. I was like, "It's running on my local machine," but unsure how we can do it. So now, in order to learn that thing, it was very hard for me to learn it. And frankly speaking, even today, I don't know how to get it globally. I tried to get the like domain, how we can connect it, how we can host it, but end to end, I haven't done it. That's not my expertise. And in order to have that expert, we have Pratik here today. So Pratik, if I tell you, Pratik is from Lucknow only. Pratik is a passer from Lucknow University. I think many of you are in the audience. You might know him because he was the first one to start the coding club at Lucknow University. And thanks to him that he made that ecosystem in university, and later on when we connected in Lucknow during the wow, I think last to last year, right, Pratik? And it was such an amazing to meet him with his Honda Highness, which he loves to ride as a traveler. And recently, as a traveler, he has been to Europe as well. And all this has been possible because of cloud, because cloud pays you well. As a early career, I'll say I think DevOps is one of the most highest paying, I'll say, role in the market. Okay, so feel free to put your questions, guys, in the chat. We are here to help you out, and please welcome Pratik here. Pratik, over to you. Thank you.
Uh, Thank you, Abhishek. Thanks for the amazing intro, and very thanks for the opportunity to be back with Google Developer Groups Lucknow. So always happy to be around. Hey folks, I'm a software development engineer too at Atlin. I work mostly around cloud and security side of things, and I'm a very like self-hosting enthusiast. So I have my home server running, and I run a few internal services, media player, and multiple home automation services within my home. And I enjoy teaching all the little things that I know. And yeah, this is part of that. You can find me around the internet by my username, and I have a website too if you want to connect on any social media. So yeah, it's here. So, okay, getting started back from the beginning, cloud, as Abhishek was just starting out, similar to that. So before while I was preparing this talk, I was thinking like what the origin of cloud will be. And for me, it was, I think, one of the textbooks in my primary school where you learn about different types of cloud, and then you take, let's say, cotton balls and try to replicate those clouds and build it out for some fun activities. But next thing that correlated cloud with computers for me was this screen. So this used to be the wallpaper on every desktop in my school's computer lab. So this is a default wallpaper of Windows XP. So another cloud memory that actually correlates to cloud, like the computing side of things. But what actually it looks like is something scary and very bland like this, like tall racks of machines closely clustered together in big factory-like settings. On top of that, there are lots of wires to configure all the servers that are present in the racks. Uh, There you can also find lots of memes around networking and how servers are connected, and this is an actual image of how data centers look like. They even have cooling on the floors. And within each rack, there is a super powerful computer that can have hundreds of cores of CPUs, hundreds of gigabytes of RAM. Like even like all the computers in your lab might not be powerful enough to compete with this single one, and we have hundreds of those lined up together in a data center. So this is the actual cloud that we are going to talk about, and how this is built, how it operates, what are the job opportunities available. So the structure of this talk will be quite straightforward. We will discuss how what cloud computing is in simple terms. Since this is a one-on-one session, I have tried to drill down most of the things as low level as possible. So because most of our audience in Lucknow is students, so then we'll have a quiz, the next portion. So please pay attention. You will be able to answer most of them if you are paying attention. Then we'll discuss some type of cloud services. Then again, a small quiz. Then we will see how the usage patterns happen between students, startups, and enterprise level usage. Then we'll take a look at how the job market around cloud looks like. Finally, we have a hands-on exercise that I'll share a link for. You can try it out on your own time, and I'll do that in front of you just to give you an experience of how to set up a small website on cloud. And finally, we have a list of resources, and I'll be sharing all the slides with you, all the work slide, like the workshop, hands-on exercises, links in the. Okay, so what exactly is cloud computing? Take a moment to observe this image. First, we can see all the devices that connect to cloud, the tablets, desktop, servers, laptops, phones. And then there are three layers. One is the application, the let's say the calendars, your chats, finance management tools, news websites, monitoring like speed tests and things like that. Then we have platform layer where things like applications that support uh, the applications running in the first layer are run. And finally, we have the bare bones infrastructure that includes all the networking, hard drives, the CPUs, RAMs, all the compute part of it. So cloud computing is basically on-demand delivery of all these sort of resources over the internet as you need it. Instead of buying all the things, for example, if you want to run your website, you might want to buy a server, but that might not be economical for you because the server costs lakhs of rupees. Then you need a whole network layer. So you need to get all the broadband cables back inside your home. Then you need power for it, uninterrupted power supply, and all those sort of things. Hard disks, configure the application, update the operating system. Too much of a headache. But what cloud did after cloud computing got started up, after it arrived, it made all the things so easy that you can control all of the layers directly from your web browser and an application as an application layer, and all the things are abstracted to you. So is cloud computing something new? The history of it started, the like concept of shared compute started around 1950s when the computers were just getting built and they were too expensive to be owned privately. So they used to share small batches of operations, and slowly the idea evolved unless a company called Salesforce actually tried to implement it. But the changing movement was when Amazon Web Services launched two services, EC2 and S3. So EC2 was for your servers, the virtual machines, the RAM.
Hello. Hi, everyone. Are you able to hear me? Can someone just ping in the message if you are able to hear me? I think there is some glitch and we are trying to fix it. Just give us a second, okay? And please help me out if I'm audible or not. And if you have any questions or anything, we can take that as well right now, okay? Am I audible to you, Arpit? Arpit, you are on mute, I guess. Unable to hear me. Is anyone able to hear me? Can someone please just ping a message? So he had a problem at his end. He is joining us just in a 2 minutes. Okay. Sorry, guys. Yeah, hi. Can you add me to the stage? Yep, Pratik is back. Okay, invited. Pratik fans are also here. I can see Mrityunjay. Hi, Pratik. Uh, Happy to have you
Hey
back.
folks, yeah,
Over to you.
I don't know how I dropped off. Wait, I'll start sharing the screen again.
Yeah, you can share your screen again. You can start it out. Okay. I'll take this just to it out. Thank you guys for your patience. And Pratik is back with his magic. Thank you, Pratik. Over to you.
Yeah, I think I was covering this slide. Uh, is it correct? Okay, Abhishek dropped off the stage. Okay, I'll continue from here. I think that's where I
You
dropped off.
were telling us about the journey of the cloud, how it all
Yeah,
started. Yep.
okay, okay. Yeah, so glad to be back, folks. Let's continue. So how this thing started was back in the time, like 1950s, when computers were still being built. There was a concept of shared compute that took place because computers used to be too expensive to be owned privately. But soon after that, after multiple iterations, around 50 years of development, Salesforce was the first one to pitch in the concept of cloud computing and successfully try to implement it. But changing movement arrived when Amazon launched its Amazon like PC2 services in 2006, along with simple storage services for uh, global storage service in 2006. So in 2020, this market was around $226 billion, but I checked the numbers today, and it is estimated to be around 1 trillion recently, and is expected to grow like really fast, like I think 20% per year. So what the hype is about? Why is it cloud computing getting so much attention, huge market share, and so much growth? The main pros of having using cloud computing in any sort of business setting is the agility that it gives you. So imagine a computer that you can scale infinite. There is no limit when you are going to stop. You pay money and you get the compute that you want. Same with storage. Imagine a hard disk that never ends. You can keep filling data into it and it will keep on scaling and it is available for you ready. Same next is elasticity that cloud computing services provide us. So you may be running, so let's say if you are running uh, video editing software and you need a powerful laptop for that, right? But in cloud computing settings, if you want to run a very powerful, demanding operation on a hardware, then you can rent it for a specific period of time. Let's say I need it for a day. I won't be spending lakhs of rupees on a specific sort of hardware that I need it only for a day. And I can scale it down the next day, shut it down. So cloud computing provides the elasticity to scale up, scale down resources. Next is cost savings. So as we get elasticity, there comes in the cost saving part. You only pay for what resources you use, and most of the things right now most of the cloud services are built per hour basis. So as soon as you start using any service, you pay by hour, and you get global reach within few minutes. So as soon as you deploy any resources, let's say you deployed something, a small website from your computer, within 2 minutes or 3 minutes, anywhere in the world, if you just have internet, you will be able to access the latest version there. So that's the power of cloud computing there. Okay, a quick stop. Will have a small quiz for you. I think okay, something going on in the chat. Okay, everything is audible. Yeah, Arpit, can we push the quiz? That would be cool. I'm not sure if how that will pop up. You're on mute, Arpit. Yeah. Sorry, can't hear you. Okay, folks in the audience, if you are seeing the quiz, can I get a yes or quiz, like if it's available to you? We'll give you, let's say, 2 minutes to complete that.
Hi, hi everyone. Anyone who's able to see the quiz now? That was amazing journey about the cloud. So, like, if I have to like start out or put it in a simple words, Pratik,
Hmm.
uh, my machine, if I'm hosting something on this machine, right? So this reminds me of I think couple of folks in the audience must have seen Silicon Valley. Anyone who remembers the that machine server और क्लाउड इंफ्रास्ट्रक्चर जो वो अपना एक ट्रक में लेके भी जाते हैं anyone who has seen Pratik, have you seen it?
I think I've seen it really long ago. Yeah.
I think that name was Ention something that was the name if I remember correctly. Folks, are you able to see the like poll or a quiz? Yes. Okay, cool, thank you Ritvik, thank you so much for confirming it. So yeah, back to our question, Pratik. So if I have to make my machine treat it as a cloud, what should I do? मेरे को अपना लैपटॉप ऐसे क्लाउड बनाना है कि you can use it or someone can host it.
So to compete with any of the cloud providers, you need a few things. So first, ensure you have unlimited power supply because it should never go down. Next will be unlimited internet. Like your internet bandwidth should be unlimited. Like no limits, no restrictions there. And finally, the toughest part, your hardware should scale to any scale that user demands. So if I want to deploy 200 websites on your machine right now, I should be able to, and all of them should work.
Okay, so people are able to see the quiz time. Okay. Yeah. So what is cloud computing? Let me just recreate and restart the phone. Okay, just give us a second. Meanwhile, Pratik, I would like to understand like so my first question would be that Abhi, I have hosted my machine. I have hosted a local website, right? And if I have to showcase it to the whole world, right? Let's suppose I have to
Hmm.
showcase it to you. How can I quickly do this?
Simplest thing would be you send me a screenshot.
Yeah, that would be lovely. But I remember my first thing when I got to know about Ngrok.
Yeah, yeah,
Amazing thing. So we in a local development environment we use that.
yeah. It still is. It is really helpful to have tunnels because the internet service providers that we have, they don't allow you to directly open, let's say, port 80 or port 443 on a machine. So we need a tunnel sort of setup that I think NGRock provides us. So
Right.
it runs on your machine and then it connects to a server, and uh, people can access the websites routed via their servers.
Yep. So, folks, if you are building your website and anything, you can simply, if you want to showcase to the whole world, what you can simply do is open ngrok setup on your machine, and the voila, whole world can see it within a second, and you need not to pay also as well for small POCs. Like what I did was when I was going for an interview, I locally exposed my tunnel with ngrok.
Nice. So yeah, folks, I think the quiz is not in the shared screen. You need to check at the bottom of the messages on the right corner, bottom right
I
corner.
think it should be popping up on their screen. I'm just
Okay.
trying to start it. Just give us a second. Okay.
Okay. Mrityunjay is asking 5 skills to know before start learning DevOps. So yeah, basically start off with learning a good programming language, maybe Python, Golang, anything, whatever you prefer. So you must have some knowledge about backend programming, right? So that you have a background of how things work and grasp around that. Next will be learning Linux. So Linux, in the sense, the operating system, how it operates, because in cloud, most of the operating systems, like anywhere you will go, you will find Linux being used. So that would be one. Next would be, I can say, you can start focusing on building small projects so that teach you how to use cloud services so that you can kind of get hands-on experience, because most of the work that you will do at any job regarding cloud or anything around that, that will be hands-on work with the infrastructure or some cloud service provider like Google Cloud Platform, AWS, Azure, or anything. And the more experience you have, the more confidence you build over there, the better it would be for you. Next, I would suggest, like, I think having some knack of security, how security works for both your applications and in the cloud provider platforms. So
Cool.
security
That's
is the biggest thing.
of course security is like first thing. Without trusting someone else's machine, how can I like host it? Right. So, folks, we are facing a little problem with the quiz. So we can simply put it out. What exactly do you think is cloud computing? So first option which we would have given will be on-demand delivery of on-demand delivery of IT resources over internet with pay-as-you-go pricing. Second option, network of remote servers to store and process data. Third option is a system to backup data online. And third is a type of weather forecasting system. What do you think cloud computing is in your layman language? You can simply tell us. So by the time folks like write it down in their chat, Pratik, you can continue. I think we'll be having trouble with.
Yeah, I was going to suggest the same. I think this quiz is not working. Maybe you can try to prepare the second one. Meanwhile,
Yeah, sure, sure, sure.
I'll need, I think, 15 minutes to reach there.
Oh,
And meanwhile, I can continue. We can skip the first one.
okay, okay, okay. Over to you, Pratik, now.
Okay, so going back to the previous slides, how cloud looks like. We discussed the origins and the benefit. So we viewed the images like how it really is, not the clouds that you see at your terrace. Okay, next thing that we'll discuss is the types of cloud that we have. So we categorically divide the type of clouds into three specific parts. First is public cloud. This is the main point of focus for us today. It is offered by some really big corporations you might heard about, Amazon, Google, Microsoft, and it is available for everyone over the public internet. It scales quickly, it's convenient, it's cheap. So yeah, hybrid cloud, we'll come back to this later, but private cloud is something, anything that is deployed at your own expense that you manage yourself. For example, you might have seen hospitals have a server room and they deploy some of their applications, the critical ones, within their servers. Same with factories. They deploy most of their critical applications that control, let's say, some machines in the factory line that gather data from the sensors within their private network inside their office or the factory setting itself. And it's available only to the select employees in the whole organization. So it's basically used wherever tight security requirements are there, and it requires maintenance and staff to keep the all the machines fixed, updated, and in running conditions. And finally, there is a hybrid deployment methodology where people or organizations you tend to use both public and private clouds, so a combination of public cloud and private cloud. So some services, if they need to be available over the internet, they use public cloud for those and private cloud for rest of the critical security stuff. And what makes this all possible? There are a bunch of cloud provider services available, starting off with Google Cloud, obviously, Azure, Amazon Web Services, Oracle, IBM Cloud, Alibaba. So all these companies provide multiple layers of IT services, IT resources across the board, from compute, storage, to networking services, security. And this is a bunch of cloud services that are available on Google Cloud. So for example, within compute itself, we have Compute Engine, which is the normal virtual machines. We have App Engine where you directly deploy the apps and it abstracts all those things. And similarly, we have networking, storage and database, identity security, big data, and machine learning operations. So I think for most of us that are active in the Google community in Lucknow, you might be aware about some of the machine learning services. You must have used the Colab, and that is also a cloud service for running your machine learning workflows, running Python code there. Today, we will discuss in the end about a small exercise about the cloud storage, with simple few lines of code. So coming to the different service models, it's important to understand the different levels of abstractions that are available over the cloud service providers. So starting off with infrastructure as a service. Okay, so these three, infrastructure, platform, and software as a service, these are the three acronyms. And we'll try to understand this from an analogy taking pizza as a service. So let's say you are craving pizza and you have four options. You make it at home. There is a fun activity place like Take and Bake where you take most of the so your supplies and go there where some of the things are available. Next is you get pizza delivered at your home, and finally will be dining out. So taking this, comparing this with cloud, uh, making it at home is more like on-prem services. On-prem is the private cloud that we saw in the previous slide. So you decide to have your own table, your own Coca-Cola, or you have your own gas, oven, fire, pizza dough, sauce, toppings, cheese, everything you manage. You go to the shop, you have your gas or oven ready to be baking the pizza, and you build the dough yourself, knead the dough, prepare the toppings, add cheese, bake it, eat it. Happy. But it has lots of steps, like too much overhead to manage. So let's say you decide to go to a take and bake service where you just take your pizza dough, tomato sauce, toppings, and cheese, and the service provider, let's say a cool place for fun activities, is providing you all the other resources that you need. Let's say you don't have an oven at home and you just want to experience how to make a pizza. So it doesn't make sense to get an oven and all the other resources just to try to make a new pizza yourself. So you can use infrastructure as a service where the core infrastructure is already managed for you by the cloud service providers, and you only use the abstracted layers. Next is platform as a service. So these guys, where pizza is delivered, they take care of making the whole pizza up to delivering it to your home, and you just sit at your sofa in your home and pop your soda open and just have a nice time. And finally, something like dining out, you go to a restaurant. Quick thing, you don't even need to clean up your mess that you make in your room after eating your pizzas and throwing all the tissues all around the room. So, infrastructure as a service that covers network, compute, storage, platform. You don't need to worry about procuring any of these services, network, compute, or storage. You don't need to update operating system. You don't need to manage the networking settings if the security is taken care of by the platform service providers. And finally, SaaS. So SaaS is software as a service. For example, we are using Communal right now. It is a SaaS platform. It's a software that we are getting to stream our communities, videos live. Similarly, Instagram, Google, LinkedIn, all these are examples of software as a service. So yeah, again, comparing it directly with the computing terms here, just remember in on-site or private cloud, we manage all the things starting from ground up. In infrastructure, until virtualization, everything is managed for us. We start to manage things from operating system up till the application deployment, the whole bunch. And in platform, we just manage the application and data. And in SaaS, everything is managed for us. We are just the consumers. So we'll take an example, simple example of deploying a website in all these three formats. So I think most of us will be aware with this annoying thing, starting with software as a service, the annoying ad that you must have seen on YouTube thousands of times about Wix. You can deploy your website. So they provide you a service where you can drag and drop, build your own website, and get it deployed instantly. But you lack the granular controls there if you want to make some custom, really niche changes that you want in your application to have, then that might not be possible with this thing. So we move to the next platform as a service. Uh, Most of us might have used Netlify, Vercel, and services like that. Similarly, a service called Heroku exists where you just code your app, you push it to Heroku, and it gets deployed. With and you can control everything from their portal itself. And finally, infrastructure as a service. Lots of things are happening in the whole speed. First layer will be the cloud provider. Let's say we chose Oracle Cloud for this. Next, we will have a specific virtual machine that is running Ubuntu 20 as the operating system. Then we deploy multiple containers, Nginx for the reverse proxy and caddy container for your access ingress from the internet. Then we'll have file system, which will be hosting your blog that is coming in from GitHub. So, and finally, you configure a domain name that has been that is your own that you own and is accessible has been set up to use the IP addresses for virtual machine. So lots of things to manage. But you can control each and every layer of this because it is customizable for you. And this is what real world applications are built on. And as soon as you start providing services, you try to move up in the platform, move from infrastructure to PaaS to SaaS. So yeah, these are the services. So you will be earning money from this. These are platforms. You will be empowering all the developers to build more and earn from that. And infrastructure as a service, earning potential for companies is just the infrastructure layer that they provide. And you build solutions on top to power SaaS, like the platform as a service and software as a service. Okay, is the second quiz ready? I think we can pop that up. Let's see if it works out.
Hi Pratik. Sorry, we have to skip that as well.
Okay, okay, no issues. Yeah, I think we are already running a tad bit of late, so to cover things up by 7,
Okay, cool,
I'll
cool, cool.
need that
Thank
time.
you, thank you, thank you, thank you, thank you.
Okay, no issues. So yeah, uh, let me check if any questions popped up meanwhile. None. Folks, feel free to ask any questions in between. I'll try to cover those too. Coming back to slides. Yeah, we understood how scalability, how availability, how less trouble, uh, and how cost efficient cloud computing is. It provides us with all the things that are managed for us, include data security. So your data will be secure on cloud platforms. And it provides ease of data recovery from backups and disaster recovery services so that you never lose your important data. Now we will take a look at scales at which different uh, like three categories operate. We will compare how students use cloud services, then how small medium businesses or startups use cloud services, and finally how enterprise use them. And then we will try to correlate with the our learning goals and the job market situation around cloud. So yeah, we'll be comparing these three, starting off with student cloud usage. So let's say students mostly post small web applications or static websites. So we have services like GitHub pages or cloud storage available where that can be done. Then basic compute, like if you want really small virtual machines that are available for free, if you just need half GB or 1 GB of RAM, they are available within all cloud provider platforms for free. And simple databases like Firebase or MongoDB, I think most of us might have used it just to build some small backend services to try to integrate it with your front end application. And mostly usage is limited to free tier and single region, and it has relatively very simple architectures and it's focused more on learning, right? And for startup, the complexity a little bit increases. They use microservices, so they need containerized services. They use managed databases like Cloud SQL, DynamoDB, RDS. So all these are database services that are deployed on cloud providers, and they manage it for you, and they can scale on infinitely. Then CI/CD pipelines is a concept of deploying your applications directly, continuously to the internet, authentication services, and monitoring. So businesses mostly focus on optimizing cloud while providing services across multiple regions across the globe. And they try to build a scalable architecture while building a MVP to production sort of transition. The main goal they try to achieve while focusing on why they use cloud is for getting a quick sense of market so that they can immediately deploy their applications to cloud and test out how users are responding to that, and they prepare for scalability on top of it. So cloud provides you ability to scale up, scale down the elasticity that is available so that they can scale up on demand when the demand is high and scale down when the demand is low, save costs. And having using cloud provider services helps you build the basic sense of security that is hard to manage in your private cloud setups or the on-prem deployments. And utilizing automated deployment, all this becomes a smooth operation so that as soon as you code it something and you just push deploy and thing gets deployed across the globe. Next is enterprise usage. So enterprises sometimes have hybrid cloud solutions, and currently most of the enterprise solutions use multiple cloud providers. For example, we saw in the previous slides, Microsoft, Google, Amazon. So most companies tend to use multiple clouds just to distribute their load across the whole globe, across multiple services because they are really critical services, and they need to ensure that they are deployed and they never go down. So the priorities themselves change. Then they need advanced security. So they have huge teams of security engineers that keep track of all the threats ongoing across the internet. Data lakes and analytics, all the big data, AI, machine learning operations. Then they need all this to support high availability requirements because they can't let their services to go down. For example, let's say Facebook, they have their own hybrid cloud setup. So they use normal cloud providers along with having their own private clouds, and they never go down. Basically, rarely it happens that something from Facebook is going down because they have that sort of complex requirement and they need the global distribution to power WhatsApp, Facebook, Instagram, everything. So main aim for them is business continuity because as soon as things go down, they start losing money in the like lakhs, crores of rupees every hour they are down. Then compliance with businesses. So all this, all the cloud providers need to follow data protection rules. So recently, India also drafted the Data Protection Act, if you might be aware, and we have the famous GDPR from Europe, European countries that they follow the data protection. So there are compliance and legal obligations that need to be fulfilled, and enterprise grade security is the non-negotiable. So these are the kind of increase in complexity that happens as soon as things begin to scale up, even with the cloud services. So a quick comparison around the services and costs. So students may be spending $50 a month would be a big achievement. Yeah, startups budget around tens to thousands of dollars. So $10,000 will be like I think 8 or 9 lakh rupees right now. And enterprise companies they have like crores of rupees of budgets per month, and they use like hundreds of services across their whole infrastructure that they have deployed across the globe. So for learning, you need to start small, master all the basics of cloud computing, understand how scaling works, and learn in small bits of pieces. And cost optimization, unless you have unlimited budget, like enterprise companies, which are spending $1 million a month, yeah, you need to save on your credit card bills. Otherwise, your parents might not be really happy. And next, after learning these small things, after you understand the basics, after you have a grasp about how things work, then you can decide on a clear career path if you want to be a cloud security engineer, cloud network engineer, you want to specialize in machine learning sort of operations or AI sort of things. And that depends on the market demand, and you can choose based on that after you are clear with the basics. So discussing the current market and the opportunities, AWS is the biggest player in the cloud provider market, having 30% of the market share. Next comes Azure and Google Cloud. And within the second quarter of this year, all these amounted to $99 billion of business, which was 25% year-on-year growth. So next year it will be crossing maybe 150 billions. So, and this is just for a quarter. So yeah, 3 months. And this is a survey that I found online regarding the challenges. So all these companies that use these services, they were surveyed to find top challenges that they face while using cloud services. So first one is obviously the cost that depends on the business to business, like how costly services they are. But the main focus that I would say for us right now as students or someone starting to build a career out of cloud services is having a sense of security and lack of resource and expertise. So these are the challenges that enterprise and small to medium businesses both are facing. So it's same. Everyone wants more talent around security, and the expertise to manage all the services. So business prioritize security and expertise, and they will pay you really good money if you are ready to solve these challenges for them. So their problems and their challenges are your opportunities. So yeah, this is a small list of available like cloud jobs that you can find around, like cloud consultant, DevOps, data science engineer, cloud reliability, cloud infrastructure, cloud security, cloud architect. So most of the beginner roles for the students over here are around simply cloud engineer or DevOps engineer, because uh, most of the job opportunities, like most of the companies that don't manage cloud themselves, they tend to use platform as a service or software as a service when possible. Very few companies use infrastructure as a service. That's why the opportunities are limited, and more so for the freshers. So yeah, really tough competitive market out there for cloud jobs. And what exactly are these people doing who work across these jobs, right? So they get the infrastructure up and running. So they manage the servers provisioning from, let's say, AWS. You get a virtual machine. Now an application needs to be deployed. So they set up the whole background of dependencies that are needed. Then they set up sync from GitHub. Like GitHub, as soon as the developers pushes code, it gets deployed. After getting deployed, we need to get some logs and metrics to see if an error happens. Okay, what error happened? I would need logs. I would need to set up alerts based on the metrics. So let's say my user count is increasing too much and my database is starting to fill up. I need to scale that up. I need to get an alert in order to operate on that so that my users don't face any outage. Then comes the network layer. Like if I want to scale my applications across the globe, then I need to configure that within the cloud providers. If I want to disallow a few countries, so let's say if my website is hackers are attacking my website from China, so I will try to block all the service, all the IP addresses coming in from China in my cloud platform. If I just want to block all traffic coming from United States for let's say 20 days, so I can do that. We can set up our own tariffs for United States on your applications from cloud. So that's how the daily job kind of looks like. And the main focus is on security, the performance of the application, service reliability. Service reliability means how reliable is your service. So let's say I open your website at 2 a.m. at the night and you hosted it on your laptop. It will be down because your laptop is turned off, right? So maintenance and managing costs and engineering on top of that. So all these are the core pointers, core areas of focus for any of the businesses that are running on the cloud. Yeah, moving on to the quick exercise. Let me open that up. I'll share that screen in a second. So this is being shared. Influences. Community notes here. Stop the screen share. Start it again. Choose the correct window. Share this. Let me check if Google Cloud Platform. Okay, yeah, it's available. So as soon as you log in to Google Cloud, so I think I'll show the login process. You need to search Google Cloud on your favorite search browser, and you will find Google Cloud over here. Go over to console on the top corner, and then you will be prompted to log in. You can log in, and you will be landing in a similar screen. You'll have a something called a project that will be visible over here. And for this exercise, let me open the document that I have prepared, which you can follow post the session to get a quick sense and replicate the same sort of things that we are trying to do right. So I created a template repository with a index.html page and a small CSS file, and all the instructions are present in here. So we will be cloning this GitHub repository to cloud. Then we will create a storage bucket. We will set up a static website and deploy it. So this is the whole flow. So first step is cloning first we will start a Google Cloud Shell. So to explain what Google Cloud Shell is, similar to the terminal that you have installed on your machine. So I think on Windows it's Command R, you run terminal, like run, and you get up the CMD. So on Linux and Mac OS it's called terminal. We have a Cloud Shell available on Google Cloud itself. And they provide us the convenience of having the terminal that can interact directly with the Google Cloud services. You will get an authorized pop-up, so allow access to it. And it should connect. Right. So you will get a terminal like this, and let's get started. So first steps first, we will need to clone this repository, and here is the step one. I will copy this from here to the terminal. I need to update the username. So my username is PM. Websites. Wait, I think the website link is not correct. It's called my GCP website. It should be public. So I'll copy it from the URL. Get clone. This thing. Okay, wait, I'll remove it. I think I did it for the demo earlier while testing it out. So clear everything. Okay. Reset, folks. Fresh start. So we will do git clone. What this thing does is git is the command line utility. I will zoom in a bit. I hope it's clear now. Git is the command line utility, and we are cloning the GitHub repository that we saw right now. And what this will do is it will download the code that we have over there inside this Cloud Shell terminal. And if I will list it now, I will have my GCP website folder. I need to change my directory to this. I will list, and we have these things. So yeah, another skill I think we discussed in the beginning, like skill to have using Linux. So this is the Linux interface, the terminal. And if you are aware about the workings here, all good. Otherwise, this is called the command line. These are programs that are installed. Get, ls, cd, or these are programs that are installed. I just navigated. So cd stands for change directory, and directory, my directory is ls is for list, and in the list, my directory is called my GCP website. I changed directory into that, and I have these files available. Now, a quick feature of Google Cloud Platform is so in terminal, it is quite intimidating for beginners to use it, and editing files directly from here could be a problem for you. So Google provides a feature to have an integrated IDE within your browser itself. I'll switch this back. So as soon as I clicked on Open Editor, I get the whole VS Code experience within my browser itself. So this is the portfolio website that we are going to deploy. My name is Pratik Mishra. Let's say I'm a student right now, and I will save it. So it auto saves. So yeah, you don't need to do anything. And I have 3 files. Now what we will do is then move on to the next step. So we logged into GCP console, opened the Cloud shell, cloned our repository, edited files, and saved the changes. Next step is creating a new bucket. So bucket in Google Cloud, as we saw in the slides earlier, is a service which provides you infinite amount of storage. So imagine a bag like I think Doraemon has one, the 3D pocket. Similar, same thing for files on the internet. You can put as many files as possible in there, and it is readily accessible. So the thing with Doraemon was he carried his pocket everywhere, but in this case, anyone can access it if you allow it to. So this is again G Cloud is the shell. Let me zoom in again. G Cloud is the program that Google provides us to interact with their cloud platform, and we are going to create a storage bucket. This is the syntax, and I need to give it a unique name. So let me call it my static website and add some random numbers at the end. So this needs to be globally unique. So because it can't be so there are millions of users on let's say Google Cloud platform and they might be using the same name. So if you get any errors over here, just try to add some random numbers at the end and it should be good to go. So if you will see now it created a bucket. So we get a next line, we get an output creating a bucket and it is created now. Moving on to this, we need to configure public access for it. So by default, the buckets that we create are not accessible over the internet. Again, it's a security feature. So you don't want to get all your data exposed over the internet. I think there was a recent hack that happened because the application providers, I think it was some cafe finder application in United States, and it was a vibe coded application on top. So they forgot to make their buckets private, and all the data was available across the internet, all the users' personal data, and people had uploaded their selfies with their driving license numbers. So securing things is really necessary over here. So the unique bucket name that we chose before, we need to just update that in the command over here and run it. So what this thing does is it adds some permissions. So it's adding IAM policy that allows all users to view. Object viewer stands for, so objects are the things that are inside bucket and viewer is the permission. And we get a big output like this. Clear out everything. Moving on to the next step. So we have created the bucket, we have set up access. Now we have to upload our files in the bucket. So we will go back, copy this command, paste it over here. What was our bucket name again? Wait, I'll try to copy it first. My static websites 123 123. So in terminal, if you put hash in front of any commands, that is treated as a comment. So I added comment, like copied the bucket name, created a comment out of it, and now I'm going to copy all the files. So wait, let me show you again.
Pratik, can you please increase the font a little bit?
Yes.
Text. Thank you. Sorry.
Yeah. Okay, so we have three files over here and we want to copy all these files inside the bucket that we created, right? So we will run this command. So this is Google Cloud Storage, copy all files. R stands for recursive, so it will copy all files that are present inside my folder. So we will remove the comment part here and run it. So you can see copying file index.html to my static website index.html, and it completed copying 3 files. So from the Google shell, all files were copied to my specific storage bucket. Now moving on to the next step, we need to set public permissions and configure the website settings. For setting the permissions, I think I have a command over here. Wait, did I miss adding it? Page? No, it is yours. Configure static website hosting. Go to the front, remove this comment part, update our bucket name. So you have to replace this your bucket name variable. Copy your bucket name from above and paste it over here. So what this will do is it will tell Google Cloud Storage that, okay, I'm hosting a static website in this bucket, and my main page is called index.html, and error page is 404. We haven't used that, so we can even skip that. So it updated the website and operations completed is 1. Now I should be able to access the thing that we created. So again, we need to copy this, open it in a browser, replace your bucket name with the exact bucket name that I have, and open it. Cool. So this is how our application got deployed. Like not application, this is just a static website, single page application, uh, just the index.html page with some CSS. So yeah, this is how we use cloud services. A small demo. Okay, going back to slides, let me pause screen share for a bit. I'll enable it again. We are 2 minutes over. Give me 5 minutes more, folks, and we should be done. So let me choose the correct screen. Slides. This one. Okay, so this is the GitHub repo. You can either use this or feel free to fork it on GitHub, and you can build your own small workshop. So I try to keep it very generic, and you can build your workshops on top of it. So yeah, feel free to reuse this thing. We are done with hands-on exercise. Okay, okay, I think I missed showing this slide. So prerequisite for having this is having Google account with billing enabled and curiosity to learn. So I think with the upcoming exercises, upcoming events with the GDG Lucknow community is going to provide you some free credits. So yeah, be sure to keep on following all the upcoming workshops. So we were not able to provide it for this particular workshop because of some delays from the other side. So okay, Google Cloud Storage. Just a small recap how it works. It never fills up. It always works across the internet and it's available globally. You never lose anything. I think I can share the link that I just deployed in the chat so that folks can just get an experience of that. Yeah, I have pasted it. I think it's not popping up. Might be take a few seconds. I'll paste it again just to be sure. Moving on. Instructions are here. I think Sahil already pasted the link in the chat. Thanks, Sahil. And yeah, open for any more questions that are. Meanwhile, like folks, feel free to drop any questions. I think we are good to close. Like we are just ready to wrap up. I will guide students through some resources right now. So just to get started, if you want to get started with your DevOps or cloud engineering journey, and you still don't know where to look for things, so this is a cool website for any of the career paths that you want to follow. Uh, roadmaps.sh, and they provide a really good interactive view of things that you should do. So starting your DevOps career, you should keep in mind like personal recommendation or opinion. This is from the author and the blue text. And I would say these are some essential things that you should know. So pick a programming language to begin with, let's say Python, then operating system, Ubuntu or RHEL, Windows, FreeBSD, anything that you wish for. Then working knowledge of having using Linux terminals, Bash and PowerShell both will do. Then some internal concepts of the operating systems. I think students that have taken operating system classes should be aware of these. Then the Git version control system, which we just used to clone repository from GitHub repo inside Google Cloud Shell. And GitHub is one. Then comes containers and some really cool concepts. So you can click on any of these, and a small summary will pop up with all the dedicated resources that you can go through to read more about these things. And finally, here comes the cloud provider. Top three: AWS, Azure, Google. They have more than 150 cloud provider services and official docs for here. And yeah, it's endless. As you can see, lots of things to learn. And in general, this is a really cool website. You can go to the homepage and check out different career paths, whatever is suits best to you. You want to be a front-end engineer, machine learning engineer, database, backend, anything. Moving on with the slides, uh, we have GitHub Education Pack. Again, I would suggest every student to try to apply for this and get the Student Developer Pack. You will get access to hundreds of resources for free, and you will even get access to cloud provider services. So I personally learned myself all the cloud services from this particular resource. So during my time when I got Student Developer Pack, I used to get $100 per year for each of the cloud services. I think AWS gave 100, Azure gave 100, GCP gave, I think, used to give $300 back in the day. So that was a huge amount for a student, and like learning those, this really helps in that learning journey. Then our resources like to learn from like cloud services or any other things in general from Microsoft. So this is a really good website, learnmicrosoft.com. Same with Google Skill Boost. I think some students are really active with this. I've seen some posts in the community, and people earn good amount of swags from following all the exercises on Google Cloud Skills. Same, something similar with AWS. And just to stay updated with all the tech news, I tend to follow Y Combinator, also called Hacker News. So just to stay updated across what's the things going on across the whole tech field regarding AI, machine learning, blockchain, and all those sort of things. So variety of tech news over here. Maybe take a screenshot of this if you want. In the end is my own Telegram channel where I post some links of things like, that I find interesting across the internet. So you might find some helpful. And yeah, that's my time, folks. Let's get back to slides. Let's see if we have more questions. And yeah, you can scan this to leave this open. This is the short URL and the QR code to check out the slides later on if you want. Okay, just now I'm seeing the poll pop up. Thanks, Abhishek, for that.
Yeah, we tried to get the
Finally,
cloud engineer here right away.
finally got it
So
working.
it's fixed now. It's fixed now. We tried to work on production. So folks, you must be seeing a poll on your screen now. And lovely session, Pradeep. And one biggest take or I'll use in my like whenever anyone asks me what is cloud, I'll simply say it's Doraemon's pocket. because that was like one of the my favorite cartoon, uh, and I still watch actually. But yeah, definitely
Yeah, same,
like
same. That's the go-to have lunch cartoon that you can
yeah.
watch.
And that was really lovely to have you here. We can take couple of questions here. Like Paul is asking, hi, I am a .NET full stack developer with 3 years of experience. How can I effectively combine my .NET skills with cloud technology, with cloud tech, and what should I focus on first to transition into cloud focused role?
Okay, yeah, I see it. I think, Paul, you should try to get into some roles like platform engineering right now. So market is booming with those sort of roles called platform engineering. So what essentially it is about some backend programming along with combining cloud and infrastructure usage. So that should give you some sort of experience to work on both your .NET skills and cloud skills. And anyways, even if you're experienced and just like you have your skills developed in .NET programming, I would say learn Linux. I think .NET is primarily Windows framework, but yeah, do learn Linux, and it will really help you out in your journey across using cloud services. So, what should I focus on first? To and yeah, again, the resources that I shared, I think the roadmaps, .sh, DevOps. So that would really help you out to guide you. So I think .NET, your first take is already covered, and since you already have 3 years of experience, you should already be aware of how like most of the services. You can use that as a checklist for your next career goals.
Awesome. Uh, that's all I think. Athar was saying thanks for this great experience. Thanks, Athar, for this lovely comment. And credit all goes to Pratik.
My pleasure, my pleasure. Abhishek, thanks for organizing this. Like, really lots of efforts go into these sort of sessions, folks. So try to attend as many as possible. Again, Google Cloud Developer Groups at Lucknow is a big thing, and I think that's the only. This is the only active community that is operating with regular sessions coming back to back. So yeah, please keep following, keep supporting Abhishek, and keep listening to whatever he says. So yeah, thanks for the opportunity, Abhishek. Really glad to be here.
Thank you
Always
for
to help out.
thank you for the lovely words, Pratik. And always happy to have you. And I'll suggest you should take the lead, Pratik, in future to start the cloud sessions here, like we discussed earlier.
Yeah, sure. I'll definitely try my best.
Okay. Okay. Thank you guys. Thank you for your time. We are एक event offline रखिए. Yep, sure. We are planning it out and definitely gonna have one in-person event soon, maybe this month itself. And we're gonna have DevFest also coming up, so stay tuned for that as well. Okay. And thank you everyone. We'll share the resources as well in the post mail. Okay. Thank you everyone. Bye bye. Have a good day. Enjoy. Thanks, Pratik.
Yeah, thank you, Abhishek. Have a nice weekend, everyone. Bye.